Yeah, hello and welcome again from AVL North America. Another episode of AVL Simulation Summer Series, LinkedIn Lunch and Learn Lifestyle episode. My name is Thomas Glatz. I'm Senior Technical Specialist here in North America for AVL for simulation topics. And today I welcome Lucas Kira. He's Product Manager for Simulation, Energy and Driving and the main man behind AVL VSM globally, as well as a special guest, Guillermo Becerra. He's Global Sales and Business Development Manager for Racing. So very happy to have the busy guys from Racing today on the show. And without further ado, we want to jump into today's topic, which is rethinking driving simulators for cost-effective development. This is live, as mentioned. I will keep an eye on comments and questions on LinkedIn for our experts. And also this recording will be available on YouTube after the session. Yeah, so with that, there's nobody better to describe and present AVL VSM in a few words to you. And I hand it over straight to Lucas.
Thanks a lot, Thomas. Thanks a lot, AVL USA, for organizing and inviting us. Also, thanks, Guillermo, for joining today as our, I would say, expert and also business development in the driving simulator and the racing field. Today, we prepared some interesting material, but also some messages about what we are facing, what we are experiencing in terms of driving simulators usage. So not long ago, we had like physical testing being reduced from proving ground, from test trips, moving to big driving simulators. And I also see move from big driving simulators to small driving simulators to static driving simulators when it's possible to extract some good development conclusions, as development time is getting quite short and a lot of pressures from different sides, from competitors from Asia, from China mainly. So then at the same time, we could see an improve of hardware equipment, software equipment. So what we would look many years ago as oh, this is only for gaming, this will not fit to a professional application. Now we need to look again and think 2 times, because even the gaming setups move it to a level that some cases, some specific applications, I would not say all of them, but some test cases we can bring to the driving simulator using some components, or even hybrid components. We can mix some gaming setups with some professional components and setups, and to extract good conclusions from the driving simulators. So that's why we normally use our, I would say, complete vehicle simulation approach. We create models that are real-time capable and that they can be developed in the office and be extended if you have more, I would say, detailed modeling for powertrain, for even controls, strategies related to chassis, powertrain. We can extend it, and as soon as it's real-time capable, we can use also in the test bed, in the driving simulator, in the hardware in the loop environment. So we always have this approach to first develop the models in the office as much as possible. We can make much faster than real-time development, and then we move with these models to different studies, different applications that are real-time related. So we are using VSM Race. So that's why we have Guillermo today. So depending on the application, we even have trucks, tractors, special vehicles like defense, or even special applications like lunar vehicles. So this is all supported with the physics of AVL VSM, and then move it to real-time environments, as you can see on the right side, an example of a big driving simulator. So today I would like to maybe focus mainly on the office part, how we prepare the models, and then how we use the model in a, I would say, small driving simulator, cost effective setup. Then maybe in the next opportunity, in the next webinar, we can have more focus on a complex setup or in a big driving simulator connected to the test bed, to the hydrogen loop bench, for example. But basically the main message, so the same model that we develop in the office can be used all around the different development phases, but also environments. So this is message number one. I like this approach. Guillermo always highlight this. So if we have the same model being used by different environments, different departments, then we can further develop the model and go into a level that the model is extremely good to replace, I would say, a good amount of physical testing. So we can bring a lot of testing from proving ground to the driving simulator. Of course, the driver in the driving simulator cannot, as a human, take like a lot of cases like 24 hours a day. So this is something that we need to make some, I would say, objectification of the assessment in the office, but also in the driving simulator. Prepare a lot of activities that we can do in advance. So in these environments, and then we select key test cases to move to the driving simulator. So that's the efficient approach. So we don't save time and resources only by using different types of driving simulators, small or big, but we also save a lot of time by assessing as much as possible we can in the office, and then go into a driving simulator when the human interaction is needed. So just pointing the workflow, why this part is so important. So between creating the model and correlating the model when data is available, or maybe previous data from previous projects or similar vehicles would be available as a starting point. This would be instead of 2-3 months, now we are talking about a few weeks when the input data is available. So we have a lot of new development approach like AI based to fit the model, to fine tuning the model. So in one side we have experts, in the other side when we need to correlate some topics that AI can take place and support the activities without the need of an expert, we use it. So this is not something that we are looking in future. So this is already the reality. And then we run cloud simulation in case a lot of let's say investigations are needed, in case we need to run maybe some optimization or even go through many parameters or maps. A combination, even full factorial sometimes is done when we apply the proper, I would say, limits. And then we finally move to a very basic setup. So you look like, okay, so it's a gaming monitor. It's a gaming steering. Yes, it is. So it's basically a very simplified version already integrated in AVL VSM. And basically it's a visualization of AVL VSM. It's a USB connection. That's not a professional application, but it's a pre-testing. So in this phase, we check if everything is smooth, so we don't block the driving simulator. And then we finally move to the big driving simulator when things are already released and check it in the office. So of course, in between 4 and 5, we also have static driving simulators. So there are always possibilities, and that's the focus for today's webinar. And then depending on the setup you have, you can really do calibration decisions, updates, improvements on different components. steering, suspension, even controls. Depending on the hardware and software toolchain you have, you can really bring a lot of things from the proving ground to the driving simulator. So I would mention again, so that number 1 and 2 is now quite squeezed into maybe 2 weeks, 1 week, when we know the inputs and when we use some AI approach integrated in this tool chain, so that we can quickly move to the other topics that are the focus. So that's the trend. I mean, it's something that the market is pushing for. All the time you get requirements from different colleagues, customers, so partners. I think that for racing sometimes it's even more challenging. Guillermo can comment, but basically that's the I would say the lean approach when we have the possibilities to reuse some data, some input data from benchmarking, or getting the data from the manual of some vehicle. So that's the approach. So how we do it? So in case of benchmarking, or even in case we have data from customer prototype itself or a new model, we immediately model and correlate in DSM, and we check in the office. Just an example of Tesla Model Y, some of the lateral dynamics parameters, if that's the focus for the investigation. So we have a look in the model in the office using a virtual driver, a very robust but still virtual driver, and we focus on different KPIs. So sometimes we even go further into longitudinal performance, braking, so more transient maneuvers. And when things like that are finished, released, then we are ready to go to the driving simulator. And I would say not even into a big driving simulator. Some hours ago, we are together. So Guillermo and I, we are in the small driving simulator, pre-testing things that would go to the big driving simulator in the next days. So, and that's the focus. So on top, you see a vehicle that was modeled from benchmarking data. That's the Ioniq 5, and we pre-tested first in the small driving simulator to check if everything is consistent. And then we had the chance to drive in the Delta S3 from Ansible Motion, the same maneuvers, the same slaloms, and to have a proper feeling, including some maneuvers like one-to-one motion. So this is basically showing a big gap between the very lean, very basic approach and state-of-the-art, I would say, best-in-class driving simulators. So in between, we have a lot of options, and those are the options that we will maybe focus today. So the office part, I already mentioned it, that we have the visualization included. So you don't need to have external or third-party visualization softwares, struggling with the toolchain, or even getting additional licenses or special tracks. So you have all in DSM for the preparation. I would like to invite Guillermo to highlight the static driving simulator that can maybe be a hybrid between gaming and professional. Maybe Guillermo can introduce the topic.
Yes. Thank you, Lucas, and welcome to everyone. The one that you see in the middle is actually, like Lucas said, is an hybrid. We are using very high quality gaming hardware, so it's not any standard hardware that you may find anywhere. It's a really high end, and combined with a real car hardware. In this particular case, we have a real dashboards with data login capability from Bosch. We have the real steering wheel, real button boxes that we have different functions on the car. and running in this case, each screen is the new Samsung Arc 55-inch, is a 1 meter radius, 3 of them covering an horizontal field of view of approximately 210 degrees. So the diameter is 2 meters, what you see there. So it's extremely compact, as you can see, running in an office in a professional way. This setup was also meant to be used for hardware in the loop, for example, vehicle control units or any other. No? So this is a very good compromise between professional, static, and cost, because you can do even hardware in the loop with a simple setup. Some ideas also, or some current projects that we are working, we will connect that type of simulator to testbeds. So you can run directly from the driving simulator the unit under test. Can be a full vehicle, can be a combustion engine, electric engine, battery, gearbox, maybe even brakes. So that's, I think it's a very interesting setup because it's very affordable, but really, really high quality components. Okay.
Yeah. So basically, the same, I would say, modules would be able to run these three, I would say, different setups, and in between in between those three, I think that there are also some possibilities.
There's a lot
we
of
wanted.
customization possible. It's always, the customer. But again, like Luca highlighted, same model, the VSM, the vehicle simulation model that runs on the office, in the static, in the dynamic, is exactly the same model. So one-time effort to correlate, to create, and run in different targets with the same model. We are not simplifying, we are not using a different model for the office, a different model for the driving simulator like many of our competitors. We have, our approach has been and will always be same model.
Exactly. And maybe it's interesting to mention also Windows-based PC. So this is quite, I would say, unique. And moving to the different possibilities, I mentioned that there would be some in between options. So I think that Guillermo can highlight. So he's testing a lot of different components. He's checking not only the technical specification, but bringing drivers and also connecting directly to customers that are using. So maybe you can highlight the main differences between. Now I see the three pictures, but we also will show later next with a single monitor. Yeah, that's why the first option.
Basically the same. We are testing every hardware that is available in the market. Like I said, there's not everyone who is supplying hardware for eSport can be used. So we are really handpicking the right ones, and sometimes even create our own interfaces, especially when we like to have everything canvas and not a USB connection. We actually here in Glatz, we are setting up a couple of them, so our customer can have a feeling of driving. You will see a multi-million driving simulator, and then go into a 10,000 or even less euro driving simulator with the same software, the same vehicle model, the same trucks and environment. So they can really have a feeling, because, if you need to do some basic function tests, like maybe does my canvas communicate properly with my hardware in the loop, or does my torque vectoring algorithm is actually working, communicating, you don't need to go to a very expensive simulator. The hour is really high every hour. And if you need to debug the model or the connections in a very expensive hardware, you are losing actually efficiency. So a target, you do those things at the office, and depending on what is your target, can be a very simple, like you will see now, ultra wide monitor, or 3 monitors, like a picture on the left. The one in the middle is actually what we have shown as a static some minutes ago. And even we have a customer running 3 projectors in a very small projection screen with vertical actuators, you will see. So we are very flexible. And again, we do not try to over-engineer is always depending on the application. We will look the right solution for the right application at the best affordable budget. Look.
Yeah. So this I would say examples number 1 and 2. So we mentioned about a single monitor. Basically, this is a 34-inch ultra wide. Actually, this is my home office setup. So this is my private setup. So I can just change the computer, put the professional, say physics from VSM. If I need to move to a different application or whatever, gaming and so on, I just use my private computer. But it's getting like simple and in a way that I can pre-test things. As I said, in a very basic setup. In this case, is USB. Of course, has some limitations. That's why we also focus on similar, I would say, hybrid setups, but with CAN bus. So Guillermo is
so actually very important to highlight the one on the left. You can even see the notebook. We are running the simulator from a notebook. Okay.
Yeah.
Again,
visualization and physics. Yeah.
Everything in one notebook. Obviously, there are some limitation, but again, depending on what your target, can be as simple as a notebook. On the right-hand side, this is already a professional visualization with ray tracing. In this case, it's a LiDAR laser scan racetrack that we have recently created with some gaming steering wheel, gaming pedals, and gaming steering motor in a gaming frame. So running with one single PC. It's a it's a big step forward from the left, especially on the visualization and the handling. Already can feel some handling, especially on the steering wheel, because the steering wheel is a good quality, and the information that our simulation, together with, in this case, is Itecmo Interact. This is the physical modeling of the track. Give to the steering is very high, so already some handling target can be already done in such a simple setup.
Yeah, and in case we need just an example, if I need to test with my laptop in this setup that is on the right side, we can just connect the cables and run directly from the laptop as well. So it's a very flexible setup. We can even have the visualization of VSM in this big monitor, 57 ultra wide. So yeah. So then the third option is on the same room, but on the side, then it's more professional. Maybe Guillermo, you can comment.
Yeah, in this case, we have a CAN steering motor, a CAN steering wheel. This particular setup allowed me to even change different steering wheels with the same steering motor. We have a CAN bottom box. And what does mean? I can change any parameter that the real car can, maybe engine maps or any other, but also because this is simulation, we have prepared those things so engineers can drive and execute setup changes. So setup changes that even the real car cannot be done without stopping. For example, ride high, anti-roll bars, wing angles, spring stiffness. So we can do those changes while driving via this bottom box that you see on the middle bottom of the screen that allow the engineer that can operate alone the system and do setup changes that later on, of course, are logged in the data set that you download after each lap, and that allow you to do quick setup changes without even, again, the need of 2 operators. No? In this particular case, you can see already we have integrated the D-Box. I think it's world famous, potentially one of the best actuators in the game industry today, vertical. We have our own interface, so we are running obviously a much higher frequency than the games. You know, games are in the area of 400 hertz. We can run 1000 or more hertz, so a lot more information. And there is, it's a very good add-on to the static, let's call it static plus vertical. So you can do heave, roll, and pitch, and add this extra immersion in the driving. I have to say, really good for the value. So we're not talking about hundred thousands, we're talking about thousands of euro, and give a lot of feedback, especially when you're looking into ride and comfort within, of course, limits. You will not look into 100 hertz, at least not for the moment, but easily below 20, 30 hertz already you can see. Again, in a very affordable setup and very small. Actually, this is running in a office. So here you can see the video. I don't know how good is the internet, how smooth is the video, no? But yeah, this is normally happening smoother, no? This is a very small setup, can be run properly.
Yeah, looks good on my end. So the video looks very good.
Yeah, and again, this is we are running at 120 hertz minimum at 4K. What you see right now. If you have a setup with 3 screens, we need to use 3 PCs. So each PC is powering 1 screen because we are running always 120 hertz minimum and 4K as a resolution. So the previous setup, the static with the 3 big screen, actually that image would be 12K, because 3 screens of 4K each one and at 120 hertz.
Yeah. And I think it's very important to mention that when we are talking about cost-effective development, so it doesn't exclude the big driving simulators. Actually, the opposite. So it is always supported by saving testing costs. So we don't want to deep dive on the big driving simulators in today's session. It would be nice to have another session because they are saving a lot of costs as well. So it's an interesting approach to show this approach. There's a sequence that we start from the very small driving simulators, but there would be a moment that they would, as Guillermo mentioned it, they would bring some limitations on development, and then we start to move to the Exapod, for example, or to the different dynamic driving simulators. So
yeah, for example, you must say how much is the price. So every hour that those expensive simulators are not running efficiently, giving you results, is a lost hour. And that hour need to be avoided by running in the, let's call it, affordable systems. And also, you need to target, when you do this investment, very high utilization. So what does it mean? Not only that you utilize it properly, but you need to have a queue of projects. No, you have several projects waiting. So you are preparing the projects in the office, in the small simulator, running in the dynamic big ones, and this should be a streamline that you never stop. So every hour that you don't use it properly is a waste of money. So we want to be efficient. So the utilization should, you cannot afford to debug models, debug communications on a very expensive driving simulator.
When there are also hardware loop systems connected, calibration activities being done, even with hardware or just software in the loop, the, I would say, different OEM programs that are running these activities would really utilize the driving simulator for calibration, for steering, for functional safety, even for like we always think about vehicle dynamics, performance, lap time, but nowadays there are like many things being done in the driving simulator. So it gets quite busy, and it needs to be, like as Guillermo mentioned, utilize it properly. So we can even change the cockpit, remove the formula, and put a passenger car cockpit, like a quarter model or even half model, and in a quick way move back to the racing setup or to the different vehicle, light duty or passenger car A, B, C. So this,
yeah, or we can mention because it's public, moon rover. We recently did a simulator for a moon rover. This is actually public. And yeah, it's again utilization. You make an investment, you want to utilize investment, think about everything what you can do there and use it the most efficient way.
Yeah. And when we are moving to these setups, maybe it would be a next webinar discussion. Then you need to think about the building. You need to think about a crane to remove the cockpit in a quick way to improve utilization efficiency. And also, you don't use just the driving simulator, but you have like operation. So this is outside. So you see the driving simulator inside the room, and then we have the guys, the colleagues operating the driving simulator, some engineer already working on the next models or in the modifications, or even like behind this table in the middle of the room, we have another meeting room so that people are working, getting data. So even having access to the, let me say, telemetry, but actually it's
yeah, actually you have a telemetry on the top left, you have a timing or whatever is in the middle up. So, you know, you have a session and you want many people to look at the data, and yeah, again, every hour, every minute that you spend there need to be useful.
Exactly. And once again, same model.
Yes,
So it's
exactly the same.
Same.
Yeah, I think this is great to see that actually without this huge financial effort that you would have to have, you can actually learn the tools, you can learn the simulation models, how to operate it, how to use it, even as a student through our university partnership programs, or with minimal effort as a startup. Test your models up front before you, for example, rent out some time at the AVL simulator here, or decide to make a big investment at some point. I think we are in a space now where you really can ramp up from the ground up, start with very reasonable cost in the office setups, but already create some value, and then obviously there's to the top, there's no limit. And as you said, Lucas, yeah, we really might want to do a second session on the racing grade simulators here.
Yeah.
Also, comment,
really
as
nice,
you say, yeah, Thomas, for example, 2 weeks ago, one of those small simulators has been in the Formula Student Austria, the event. We put it in the middle of the box, run it for almost the whole week. So it's also easy to transport, to move it, you know. Yeah, it's solid, and it's something really, affordable, no?
Yeah. And actually, there are a lot of Formula Student, Formula SCA teams using VSM, so they already have the model. So it's just a small step for them to move to a basic setup.
Yeah.
Correct. Yeah, and also it works plug and play. As we have seen directly at the RMX AVL's conference earlier this year in Michigan. We had setups. We saw it live. That we can also demonstrate it live here in the US. And yep, if you're interested, please reach out to some of us or to your global local affiliate. Yeah, with that, I think we are at the end of today's live stream. I would like to thank you both. Thanks Guillermo, and thanks Lucas for this super interesting overview, the great videos and a little bit of insight into the racing simulator at AVL's headquarters. Yeah, thank you so much. Next episode, same time, same place next week, will be about innovative vehicle thermal management development. So we will look a little bit deeper into the powertrain and the thermal management system and how we can model this mainly in Cruise-M. With that, I'd like to thank you for the day and have a great rest of the week, everybody.
Yeah, thank you, Thomas.
Thank you for joining.
Have a good
Bye.
day.
Thank you for joining.
Bye-bye.
See you.